Today we're going to take a look at polynomial operations. So there are four major operations in every level of mathematics. You can add something, you can subtract something, looks like an N, you can multiply, or you can divide. And it doesn't matter what kind of mathematics you're doing, what level of mathematics you're doing, you're always going to do the same four operations: add, subtract, multiply, and divide. The same thing is true with polynomials. So what we're going to do is kind of take this in three different sections. We're going to talk about adding and subtracting. Then we'll take a look at multiplying and then dividing. And we're going to start very basic in division. We're just going to look at things like dividing out one term from the whole polynomial. So remember, polynomials are simply a bunch of terms that are put together and they represent a function. And we have monomials, which is one term, binomials, which is two terms, trinomials, and polynomials. And we can add, subtract, multiply, and divide those. So when you're dealing with addition or subtraction, you are really looking at just combining like terms. So I like to color code when I'm doing adding and subtracting, because I can go in and quickly find all of my x squareds and they turn into one color. All of my x's turn into another color. And notice that the number and the signs go together. And then my constants, or what I like to refer to as naked numbers, they're in a third. So when I go to add them, I can kind of look at them separately and I can say, oh, I'm adding, my blue terms together. So I can say 3x squared plus an x squared. I can look at my green terms, and my constant terms, 4 plus a negative 13. My like terms are the same color, and so I can see kind of visually what goes with what. So if I had 3x squared and I add another one, I have a total of 4x squared. If I had 11x and I added negative 5, that's the same as like taking away 5. I would have 6 x's, and if I had 4 and then added a negative 13 or took away 13, I would have a negative 9. So it kind of lets me look at each thing individually, and then my final answer is all of that just put back in standard form. So just that process of combining like terms. Let's take a look at maybe one that has missing pieces or extra pieces, or one polynomial is a different size as a second one. So if I look, I want to find out if there are any more cubes. There are no other cubes. So then I can move on to my next degree. I can find all my squares, my linear terms, and my constant values. According to my operation, I am adding them. So notice what happens here. I don't have anything to add it to. So I can say I have 9n cubed, but there are no n cubes over here. I have a negative 4n squared, and I want to add it to a negative 2n squared. I have a 2n, and I want to add it to another n. And then I have a negative 10, and I want to add it to a 7. I can look at each like term separately, and I would have 9n cubed. Negative 4 plus negative 2 is negative 6n squareds, 3 n's, and a negative 3. And then in order to put it all back together, you put it in standard form. And that's it. Subtraction runs, my apologies. Subtraction runs the same way, but this is kind of one that students make more mistakes on. So I'm going to start the same way. I'm going to look for my like terms. So square values here, my linear values, and my constant values. So starting off the same process, I look in the first set of parentheses. I did have a cube value, and according to my operation, I'm going to subtract it. Now over here, there were no cube values. So I could say minus no cubes. I do have a squared value in my first set, and I want to take it away from the square value in my second set of parentheses. In my first set, I had a linear, and I want to take it away from my linear value in my second set. But notice that there in my first set are no constant values. So I don't have anything, and I need to take away 17. So notice that there's nothing in orange over here. So we want to make sure we represent that there was nothing from the first set of parentheses. So 5 minus 0 is 5. Negative 2 minus 2 is negative 4. 2 minus 2 is 0. And 0 minus 17 is negative 17. Put it all back in order and you get 5k cubed minus 4k squared plus no k's minus 17. Now, we don't typically see a term with a coefficient of 0. So you could rewrite it as saying 5x cubed minus 4x squared plus no k's and a negative 17. So you may or may not see those terms that have a 0. So let's try another one. So again, start highlighting all of your like terms. We have our quadratic term, our linear term, and our constant term. So I like to write mine in standard form ahead of time, so it's like kind of like the color coding. So if I look in my first set and I look in my second set, I don't have any cubed values in my first set. So I'm going to say I have no cubed values, and I am taking away a negative y cubed. I have 4y squared, and I'm taking away 2y squared. I have a y, and I'm taking away a negative 5y. And I have a negative 3, and I'm taking away, I missed highlighting a constant term. So I have a negative 3, and I'm taking away a 1. So when I go through and I combine like terms, 2 negatives make a positive. So this gives me 1y cubed, 2y squared. Again, 2 negatives turn into a positive. This gives me 6y and negative 4. So I could write it y cubed plus 2y squared plus 6y minus 4. If we look at multiplication, see if I can get this to move. I don't like old school FOIL, first, outer, inner, last, or to distribute. I like what is known as the box method. For me, the box method is very, very clean. You don't lose as much things. you do have to set it up a little bit based off the number of terms. So if we look here, this has 2 terms in it. And if we look at our second set of parentheses, it has 3 terms in it. So I'm going to build a box that is 2 units high by 3 units wide. So 2 units wide, or 2 units high by 3 units wide. Let's see if I can get those more spaced out. There you go. And what I do is write a term on each edge of that box. And I'm going to multiply them together because 2 sets of parentheses side by side indicate multiplication. So w times w squared gives me w cubed. W times 2w gives me 2w squared. W times 1 gives me 1w. And I do the same thing for the bottom row. Negative 7 and w squared gives me negative 7w squared. Negative 7 and 2w give me negative 14w. And negative 7 times a positive 1 gives me a negative 7. So the box method does all the multiplication, sets it up. You just fill in the box, but it's in a nice, clean, and organized way. What's also really nice is notice where your like terms are. They line up diagonally. And so we would have w cubed. And if you combine your like terms, okay, negative 7 plus 2 gives me negative 5w squared. Negative 14 plus a positive 1 gives me negative 13w. And then a negative 7. So this product rule, the box will work 100% of the time, no matter how big your polynomial is. Let's try this one. So this one has 1, 2, 3, 4 different things being multiplied. So what I'm actually going to do is kind of take them and split them. Take care of 2 and then take care of the other 2. So I'm going to build a box that is 1 unit by 2 units. Then I'm going to build another box that is 2 units by 2 units. And it looks something like this, where my terms each take a box, and we're going to multiply them together. So this gives me negative 3a and negative 15. I don't have any diagonals, so I don't have any like terms, and I'm just going to kind of hold that for a minute. I'm going to do the same thing over here to these 2 terms. I have a minus 2, a plus 8, and then I fill them in using multiplication. So a times a squared. A times 8 is positive 8a. Negative 2 times a is negative 2a. And negative 2 times 8 is negative 16. We have a bigger box, so what do you notice happens here? We have some like terms. So in my first box, I did not have like terms. In my second box, I did. So negative 2 plus 8 is negative 6. I'm sorry, positive 6. And earlier I split them up right here where there would have been a multiplication symbol. So I still need to multiply them again. Here's why I like the box method, because it doesn't matter how much you have to multiply, you just build a box. So this one had a product that was 2 terms and 3 terms. So I need to build a box that is 2 units tall and 3 units wide. Each term takes an edge of the box, and we fill that box in using multiplication. So this is negative 3a cubed, negative 18a squared, positive 18a, negative 15a squared. 15 times 6 is 90a, and negative 15 times 6 is 90. Negative times negative makes a positive. I've got a bigger box, so I do want to check my diagonals. So this would come out to negative 3a cubed, and along those diagonals we add them together. So negative 15 plus negative 18 is negative 33. Negative 90 plus 18 is negative 72a, and 90. For number 9, remember that this cube means that your base shows up 3 times. So you would say 2c plus 5d times 2c plus 5d times 2c plus 5d. You would build a box for the first two, and then take your answer and build the box with the second. Let's look at, let's say, number 10. This is a good one. Let's take a look at the first set of parentheses. This is 3 terms. The second set is 3 terms. So I need to build a very big box. I need to build a box that is 3 by 3. So 3 units wide and 3 units tall. Each term takes an edge of your box, and then again we fill in using multiplication. So 3 times 2 is 6, m to the 4th. We have 3 times 5 is 15, m cubed. And the way I do my exponents is I say like, hey, I had 2 m's come in from the side, 1 n come down from the top. So I had 2 and another 1, which gave me 3. 3 times negative 9 is negative 27 m squared. Negative 8 m cubed, negative 20 m squared, positive 36m, positive 2m squared, positive 5m, and negative 9. And again, we have a bigger box, so we check those diagonals. There are your cubes. There are your squares. There are your linears. So when they come out of the box, we're going to add up your blues with your blues, your greens with your greens, your oranges with your oranges. So we end up with 6m to the 4th. 2 minus 20 is negative 18. And another 27. This is negative 45m squared. 5m plus, oh, I've missed one. I missed the blue one. Negative 8 plus 15 is positive 7m cubed minus 45m squared plus 41m minus 9. And so we would say negative 8 plus 15, that gave me a positive 7. The 2 minus 20 minus 27 gave me a negative 45. And that 5 plus 36 gave me a positive 41. We'll take a look at some of these geometry questions together, but what I wanted to go through is division. Okay, division is an all or nothing deal. Either everything can be divided or nothing can be divided. So when you're dealing with division, what we're looking at is there something that could be divided out of the numerator and the denominator? If I look at the numerator, I know that 9m cubed can be written as 3 times 3 times m times m times m, and I want to subtract it by 24, which is 3 times 8 m divided by 3m. So what I'm looking for, and I've kind of done these in colors, is something that can be canceled out that is both yellow, blue, and green. All right? So they all share the number 3. They all share the letter M. It is an all or nothing deal. So when you do, you are left with 3m squared in the numerator minus 8m, and then everything in your denominator is gone, so you could replace that with a 1 or just leave it like this. So you're saying, what can I divide everything by? Not just some stuff, everything. So let's look at 14. So I'm looking at 20x cubed negative 4x squared and a negative 8x and a 4x. Well, kind of just looking at it, I do see everything can be divided by 4. So I know 20 is the same as 4 times 5 with 3 x's. I want to take away a 4 times 1 and 2 x's. And I want to take away a 4 times 2 with 1x divided by 4 times x. So again, do they share the same number? Yes, every color shared the number 4, and every color also shared the letter x. We also call that the greatest common factor. So they all share the number 4, they all share the letter x, so we would say the greatest common factor can also be called 4x. And so we are left with 5x squared minus 1x minus 2, all divided by nothing, or we can just say 5x squared minus x minus 2. Okay, let's try another one. Let's try 16. So I'm going to take just a quick look at these numbers. I notice that all of them have a 6 in common. They all have a 6. So I would rewrite this as 6 times 5. 2, 3, 4, 5, 6, 7, 8 with 5 C's and 2 D's. Want to take away. 36 can be written as 6 times 6. 1, 2, 3, 4, 5, 6 C's, 2 D's. 6 can be written as 6 times 1 with 3 C's and a D. And we want to divide by 12, which is 6 times 2, and 2 C's and 1 D. So again, all or nothing. So it has to be in the red, blue, green, and yellow. So we already said that they shared a 6, but they also share a C, and they share another C, so we say they shared two of them. And they also shared the letter D. So one red, one blue, one green, one orange. Even though we have extra D's that are red and extra D's that are blue, we have no more green and we have no more yellow. So we say my greatest common factor is 6C squared D. So what I'm left with in the numerator is 5 with 1, 2, 3, 4, 5, 6 C's left and 2 D's. We have a negative 6 with 4 C's and 1 D. And we have a positive 1 with 1 C. And in the denominator, we simply have the number 2. So we're not trying to make it overcomplicated. If you can kind of recognize some of these exponents and some of those exponent rules, that might make things a little bit easier. But again, you can do long math and it might take you a little bit longer, but you're less likely to make mistakes if you do it the long way. I believe you have a short Delta Math. It has all of adding, subtracting, multiplying, and a little bit of division. The multiplication is done using the box method, so you have to build the box. You have to tell it how big it is, you have to fill it in, you have to modify it, and do those things. But it's really not a bad assignment at all.